Today I'll be talking to you about mean, median, mode, range, harmonic mean, and geometric mean. First, we'll start off with mean. Mean is the average of a data set. How you find mean is you first sum up all the data in the certain data set, and then you divide by the number of data in that particular set. Mean is also non-resistant, which means outliers affect the outcome. An example. The data set shown here is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So for the steps, you first add up all those 10 numbers to get a total of 55. For step 2, since there's 10 numbers in the data set, you do 55 divided by 10 equaling to 5.5. So your final answer is 5.5. Median. Median is the middle value of a data set. It must be arranged in numerical order before you can find the median. For an even number of data in a data set, you find the two values that are in the middle, then you divide by 2. Median is also resistant, meaning that an outlier, whether it's an extreme outlier or in the middle, should not affect the outcome very much. An example. The data set shown here is 1, 3, 6, 5, 7, 8, 2, 4, 9, and 10. The steps. First, we have to order the numbers numerically. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. As you can tell, there are 10 data values in this set, and which is an even number of values. So we find the two middles that are right in the middle. As you can see, I highlighted 5 and 6 because those are the middle numbers. Then you do 5 plus 6 equaling to 11. Divide 11 by 2 equaling to 5.5. So the median is 5.5. Mode. Mode is the most occurring value in a particular data set. It is resistant, meaning that an outside value does not change the outcome significantly of the original mode value. You can always have more than one mode, or you can have none. If there is no mode, so no value that occurs more than the other values, then you are supposed to write none instead, or no mode instead of writing 0, because 0 could be a value in a particular data set. An example. There will be 3 examples. The first one, as you can see, the data set is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the mode is none because there is no value that occurs more than others. Example 2. The data set shown here is 1, 2, 2, 3, 4, 5, 5, 5, 6, 7, 8, 9, 9, and 10. As you can see, I highlighted the 5 because 5 occurs 3 times, but the other values occur either once or twice, meaning that the mode in this data set is 5. Example 3. As you can see, the data set is 1, 2, 3, 4, 5, 5, 7, 8, 8, 8, 9, 9, 9, 10, and 10. As you can see, 8 and 9 are both highlighted because both of those two numbers have 3 of the same value. So there's 3 8s and 3 9s. But the other values that are not highlighted only have 1 of that value or 2 of that value, meaning that the mode is 8 and 9. Range. Range is the difference between the largest value and the smallest value in a particular data set. Range is somewhat non-resistant. Example. The data set shown here is 1, 2, 3, 4, 4, 5, 6, 7, 8, 8, 9, and 10. Now for the steps. As you can see, the first step is kind of a gimme because I already highlighted the smallest number and the largest number. the largest value is 10 and the smallest value is 1. So then after you find those two values, in order to find the range, you do the largest value minus the smallest value, and in this case it would be 10 minus 1. So for the final outcome, your range is equal to 9. Harmonic mean. Harmonic mean is the reciprocal of the arithmetic mean of the reciprocals of a specified set of numbers. So for n amount of numbers in a particular data set equals the harmonic mean is n over 1 a1 plus 1 over a2 plus so on, going all the way up to 1 over an, which is an a1, a2, an are just each number in the data set, n meaning the last number in that data set. An example. So the data set shown here is 1, 2, 3, and 4. The steps. N equals 4, meaning that there are 4 numbers in this data set. A1 is 1, A2 is 2, A3 is 3, and A4 is 4. So what you do, it would be 4 divided by parentheses 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. When you add all the denominator fractions together, it equals to 4 over 25 over 12, equaling to 48 over 25, because when you divide by a fraction, you do the numerator times the reciprocal of the denominator, which is 4 times 12 over 25, equaling to 48 over 25, which the final answer to be 1.92. Geometric mean. Geometric mean is the average value of a set of n integers, terms, or quantities expressed as the nth root of their product. An easy way you can do it, if the amount of the data set is 2, you can do n over x equals x over n. X would mean it's the geometric mean, and n and m are the values in that data set. And you can solve for the geometric mean by cross multiplying and solving for x. The picture here is the formula actually shown. As you can see, there's the g, meaning geometric mean, and the amount of values that are in that particular set, which equals to the nth root of a1 times a2 times a3 and so on until you get to an. Example. First example. There are total 2 examples in this category. Find the geometric mean between 10 and 14. So there are 2 values in this data set, 10 and 14. So first you can either find the square root of 12 times 14, or you can do 12 over x times x over 14 and solve by cross multiplying. I'll be showing you the method of cross multiplying. So when you cross multiply, you get x squared equals 168, which is basically 12 times 14. So the geometric mean, which is x, is the square root of 168, which is approximately around 12.9614814. Example 2. 12 is the geometric mean between 8 and what other value? So in this case, the geometric mean is given and you are finding the missing value in that data set. So first, again, I'll do the cross multiplying way, because that's the easiest when you're dealing with 2 numbers. So it will be 8 over 12 equals 12 over x. Again, 12 is a geometric mean, so 12 in the formula shown on the previous slide represents x. 8 and x represent the values n and m. So it would come out to 8x equals 144 when you do cross multiplication. So the other value, which in this case is x, equals 18, because that you get that number from doing 144 divided by 8 to solve for x.